So looking ahead this week, we've got we're going to do the last step today. So you'd want to have out your supplemental note sheets, your cheat sheet, if you will, your steps, your plan the worksheets, because we're going to fill in the last one today, and then we're going to graph the rest of the week, and then we're going to open things up. The test is going to be next week. Right now, I'm tentatively looking at like Monday's class is going to be a check-in, and you can take the test kind of a deal. If you're sitting at, if you're in class or at home, you can opt out of taking the test, or we can have questions and answers. Either way. With that also being said, this test, so next week's test is going to be a summative, is going to come in two parts. There's going to be a multiple choice type thing on its learning, and then you're going to have to also submit graphs. Okay? So it's going to be a two-part type test. And if you don't do one of the parts, you're not going to get those points until that gets done, kind of a deal. Okay? So it'll be a two-parter type of thing. Okay? Yes. So with that being said, let's jump into talking a little bit about horizontal asymptotes. So that's step 2 on our extra sheet. So when we're determining the horizontal asymptotes of a rational function, we will compare the degrees numerator to denominator of them. And so we've got 2 or 3 different scenarios. We've got small over big. What's that one? What do you got? That's a y equals 0 is our horizontal asymptote. Okay? We've got where they're the same. What's that one? And where do I get A and B from? The what? The lead coefficients of the top and the bottom? Is that what you were trying to say? Yeah. Okay, because that's not what was coming out. You know what I mean? But yeah, so it's y equals A over B, and A is the lead coefficient of the numerator, and B is the lead coefficient of the denominator. Okay? And those are all great. Love those. Okay? But today, I actually want to focus in on that third scenario, when we've got big over small. And normally, that's a none or a no horizontal asymptotes case. Okay? But that's what we're going to actually focus in on here today. Is when we don't have a horizontal asymptote. Okay? So, what we are specifically looking for is we are specifically looking for if the degree of the numerator is 1 degree higher than the denominator. Okay? So if that difference, if it's big over small, and it's bigger by 1, and only 1, we get what's called a slant asymptote. And a slant asymptote is just that. It's an asymptote that's slanted. Okay, so we just got to graph a line. Okay? And that line's not going to be vertical or horizontal. It's going to be on a slant. Okay? In order to find the slant asymptote, we do the division. So we're just going to actually do that division. Okay? And we can do that division either synthetically, if it's a special linear factor, or a special linear factor, or we can do it using long division, one of the two different ways. So for instance, if we have f of x equals x squared plus 4 over x minus 2, we can do the division. So if we wanted to, we could say, all right, well, x minus 2 is equal to 0, so then x would have to be equal to 2. And the numerator on the top has coefficients, of 1, 0, and 4. Drop it like it's hot. Multiply, add, multiply, and add. Okay. If we wanted to do it long division way, this would be x, and then we'd have x squared minus 2x, and we change our signs, and we have 2x, and we drop the 4, and then we'd have plus 2, and we'd have 2x minus 4, and we'd change the signs, and we'd have 8, and it would all be great. Okay? So the first step in finding slant asymptotes is to do the division. And you can do that division either synthetically or long division. You see you get the same thing. The 1, so here's the 1, there's the 2, and the remainder is 8. Okay. The second thing that you're going to do to find the slant asymptote is you're going to drop the remainder. You will get a remainder, because otherwise you did step 0 wrong. You know what I mean? Okay. So you will get a remainder, and you're just going to straight out drop it. So you're going to totally forget about it. And then our last step is your slant asymptote is going to be of the form y equals mx plus b. And so in this particular case, our slant asymptote was y equals x plus 2. And we get that from right here or right there. Now, when it comes to on the graph, it's an asymptote. So how does it go on the, or I shouldn't say how it goes, how do we put it onto the graph? It's a line, right? Because it's linear. Asymptotes are lines. But how do we put it, how do we physically put it on our graph? So we graph it, right? So we find the y-intercept, use the rise over run to get more points. And we do a dash, right? Because it's an asymptote. Yep. So it's a line, so we would do plot B, and then use M, but then more importantly, it is dashed. So that leads us into our last fill-in. Step 6, we need to find the slant asymptote. And we find the slant asymptote by doing the division, dropping the remainder, and writing it in y equals mx plus 1. Let's jump into some. Alright. Sketch the graph, include any intercept asymptotes at home. Alright, so let's start from the top. Step 0. Step 0 on our sheet, on our extra sheet that we should have up. What is step 0? Simplify it?
Yeah.
Simplify? Okay. So step 0 is simplify. Can x squared minus 3 be factored? Two numbers that multiply together to be -3 and add to be 0? Nope, can't be factored. So since x squared minus 3 can't be factored and x squared or x minus 2 can't be factored, that's factored. Step 0, done. Step 1. Ethan, what's step number 1? How do I do that? Should be written right on your sheet right next to it. So you didn't write down how to do the steps. You just wrote the steps down.
Yeah.
Okay. What was that, onliners?
Set the denominator equal to 0.
Thanks, Eric. We set the denominator to 0. You probably want to write that down right next to step number 1. Okay? So x minus 2, we want to set that equal to 0 when we want to solve that, right? Okay? So my domain is what?
All real numbers and x
Doesn't equal 2. So all real numbers, but x cannot equal 2. Okay? What's my vertical asymptote then? 2. No, 2 is a number. X equals 2 is a vertical line. Okay? Step number 2. How do I do that? Somebody other than Miss Bailey. Hey, what do you got? Compare the degrees, right? Okay, degree of the top is 2, right? Because we can't just say, because now we can't say big over small because we got that step 6 now. Okay, so degree of the top, 2, degree of the bottom, 1. So that is a big over small case, yes, but it also differs by 1. So my horizontal asymptote would be none, but I'm going to put a little asterisk by it too, because it differs by 1, and we just learned on the last slide that tells me we have a slant asymptote. Okay. Step number 3. Find the y-intercept. How do we find the y-intercept? So if I put in, so I got to find basically f of 0. So that's going to be 0 minus 3 over 0 minus 2, which is going to be negative 3 over negative 2, which is going to be 3/2. So I get a y-intercept at 0, comma 3/2. Step number 4, somebody other than Natasha.
Set the numerator to 0 and solve.
For y.
Oh.
What does that give us?
The x-intercept.
Gives us the x-intercepts. Yep. So I set the numerator now equal to 0. And I solve that. So that gives me 2 x-intercepts. 1 at the square root of 3, comma 0. And 1 at negative square root of 3, comma 0. Step number 5. That's number 5, right? Okay. Do we have any holes? Why not, Noah? We didn't factor anything out, so we have no holes. Okay. Now we come to step 6. Step 6 says we need to find the slant asymptote. So we're going to take x minus 2 and we're going to divide it into x squared plus 0x minus 3. Now we can do that long division way, or we can do that synthetic division way. So we do the division, drop the remainder, and what's left over is my slant asymptote. So my slant asymptote in this case would be y equals what? X plus 2. All right, so let's take all of that and let's put it on our graph now. So first off, we had a vertical asymptote at x equals 2. We didn't have a horizontal asymptote. We had a y-intercept at 0, comma 3/2. We had an x-intercept at the square root of 3. What's the square root of 3? 1.3. 7-ish. Right? Because the square root of 4 is 2. Square root of 1 is 1. So it's probably in that 1.7 range, which it is. 1.742. So there's one of them. And then we had one at negative square root of 3, comma 0. So we've got one there. We didn't have a hole. And we have a slant asymptote at y equals x plus 2. So that's going to have a y-intercept of 2 and a slope of positive 1. So that's up 1 and right 1, or down 1 and left 1. And we said that that goes on our graph as a dashed line. We have 3 points on our graph in here, so our functions can't cross the vertical asymptote, comes up, and it ends right along the slant asymptote. We have that. Now we just need to try some points over here. So like 3. Three squared is 9. 9 minus 3 is 6. 3 minus 2 is 1. So we have 6 over 1. 5 and 6. 7. 49 minus 3 is 46. 46 divided by, oops, I don't know why I did 7. Why did I jump to 7? Oh, that's fine. 7 minus that is 5. 46 divided by 5 is 9, a little bit more than 9. 2, 3, 4, 5, 6, 7. 1, 2, 3, 6, 7, 8, and 9. So up there. And there you go. There's your function. Okay. You try that one. So that's what I got for my side information, the stuff that I'm going to need to use my graphs. Vertical asymptote at x equals 2. Y-intercept at 0, negative 5 halves. 2 x-intercepts at 1, 0 and 5, 0. And a slant asymptote to y equals x minus 4. Yep. Put that all in the graph then. Yeah. We had a y-intercept at negative 2.5. We had an x-intercept at positive 1 and 2.5. We had a slant asymptote. 1, 2, 3, 4, and then 1. slant. Add in a couple of extra points here. Little step 7. What do we have? We had x squared minus 6x plus 5 over x minus 2. So 1 would be 3. Yeah, we can do 3. So let's do -1. So that's going to be 1 plus 6 is 7 plus 5 is 12. All over -3, so that's -4. That's a good spot right there. Then let's do +3. 9 minus 18 is -9 plus 5 is -4. 3 minus 2 is 1, so that's going to be -4. That should be enough. Comes in along here, comes out, shoots down, ends along the asymptote, comes up, and ends along the asymptote. We're always going to end along an asymptote, so with a slant asymptote, we're definitely going to end along it too. Questions on that? Work 15 worksheet. We can start that. We can do number 1 on it. Here's number 1. It's a graph. X squared minus 2x minus 8 all over x minus 3. Oh, great one. Love it. Probably could do number 2 also. Tomorrow there will be a video for you to watch with some extra problems and some more in-depth explanations of the things that are going on.